I am excited to introduce the newest addition to ION's well-known and trusted line of vibrators. The AHV-IV Commander is the product of many years of research and development in response to the needs of our large and diverse customer base. What is the Commander? It is a vibratory seismic source vehicle built on the field-proven AHV-IV platform. A number of physical design enhancements have been added to our 60,000-pound vibrator to create a new PLS 364 shaker model. Our customers can take advantage of these improvements in two ways, either as a new vibrator purchase complete with a full set of performance enhancements, or as a conversion kit to an existing AHV-IV 362 vibrator. This conversion is available as a field upgrade by crew personnel. ION has decades of experience building vibrators. Our customers are using these vehicles around the world and provide us feedback on what the industry needs from vibratory sources in order to improve the quality of the acquired seismic data. We found that there are 5 areas where advancement is needed. There is increasing evidence that the actual force driven into the ground is not accurately estimated by the weighted sum recorded at the vibrator. Industry papers show that a more accurate ground force estimate is crucial to the simultaneous source techniques that are setting new vibrosize production records. Increased useful energy output results in an improved signal-to-noise ratio, better illuminating the target. And if a vibrator can put more force into the ground, the crew may be able to reduce the number of vibrators used, which improves productivity and reduces operational costs. Broader bandwidth results in better resolution. For this reason, any improvement in this area is of great interest among processing geophysicists. Source repeatability refers to the ability to produce a consistent sweep over various ground and coupling conditions, enhancing the vibrator's physical design to be less affected by the area where the ground is in contact with the base plate, takes some of the uncertainty out of the quality of the ground force. And finally, reducing the harmonic distortion means lowering the relative power of the harmonic components compared to the power of the fundamental frequency, which again improves the signal-to-noise ratio of the signal that is put into the ground. Now let's see the Commander results in each of these areas. On this slide there are 2 measurements for the Commander and the pre-Commander vibrator. On the left, the amplitude spectrum of the weighted sum estimate calculated using the data from the accelerometers on the base plate and the mass. On the right side, the amplitude spectrum of the data simultaneously recorded using a geophone 1000 feet downhole. The sweep in both cases is from 1 Hz to 201 Hz at 70% of the peak force. Comparing the top left to the bottom left graph, one might think that the pre-Commander vibrator was putting a flat spectrum into the ground. Looking at the downhole data, not the estimate, it is clear though that it is not the case. The energy is not flat when measured 1000 feet down. The pre-Commander vibrator appears to have reached a limit at around 150 Hz, after which it was not able to continue inputting the same level of energy into the ground. This limitation was not captured by the weighted sum average. The Commander results show that the shape of the weighted sum estimate curve is more similar to the downhole data graph. The angle of the roll-off at around 150 Hz is a better approximation of the actual energy decay. Overall, the weighted sum estimate of the Commander more closely resembles the actual amplitude measured on the downhole geophone. Now let's move on to see the energy output of the Commander more closely. On this slide, the amplitude spectrum of the pre-Commander vibrator is shown as recorded by a geophone that is installed downhole at 1000 feet. The black line is added to trace the curve for comparison with the results of the Commander sweep. As the Commander amplitude spectrum is overlaid on the graph, it is clearly visible that it produced a higher energy output across the full bandwidth. Closely related to energy output is broader bandwidth. When the energy is higher across the whole spectrum, there's a better chance to get additional octaves of useful bandwidth for processing, which results in improved temporal resolution. The improved signal-to-noise ratio can be observed in the highlighted areas of the seismic data recorded using pre-commander and commander vibrators as sources. Let's see how the commander improves source repeatability. The vibrator works on the Earth's surface, which can change dramatically from one location to the next. Sand, rock, tree stumps, etc. The base plate is often not evenly supported. Depending on the design of the vibrator, this leads to more or less variation in the radiated energy as the vibrator moves from one spot to the next. To demonstrate that the commander is less affected by the varying coupling conditions, we devised a simple experiment. First, both vibrators were used with optimal coupling. The base plate had contact with the Earth over its entire area. The energy was recorded downhole, and the sweeps are represented by the plots on the left. Afterwards, the same experiment was repeated, with one exception. The coupling condition was changed by placing two 2x6-inch boards underneath the base plate, one in the middle and one at the edge. Comparing the differences between the top two and the bottom two amplitude spectrums, we can see that the impact of the changing coupling conditions was much less significant on the commander than on the other vibrator. The similarity between the bottom two plots shows that the energy output of the AHV-IV commander remains consistent across different simulated ground conditions. And at last, let's see how the commander addresses the need for reduced harmonic distortion. These plots show the 2 to 160 sweeps energy over time. The amplitude of the signal that is recorded using a geophone 300 feet down is represented by color going from red, strongest, to blue, weakest. As expected, the fundamental frequency is the highest energy, evidenced by the red line across the sweep. The harmonic frequencies can also be discerned easily. There are two important observations that have to be made when comparing the results. First, the longer and thicker red line on the right means that the commander puts more fundamental energy into the ground across the sweep. And second, the increase in the energy at the harmonic frequencies is not as pronounced as the increase in the fundamental energy. In fact, with a closer look, one can find that at low frequencies the harmonics are even weaker with the commander. Total harmonic distortion is calculated as the ratio between the energy of all harmonic components over the power of the fundamental frequency. With the commander, this ratio is lower. The AHV-IV commander delivers on all 5 areas where improvements were needed in the industry. It provides a more accurate weighted sum estimate, puts out more energy over a broader bandwidth while improving the repeatability of the sweep and reducing the total harmonic distortion. Our customers can have the commander advantage in 2 ways. As a new vibrator purchase, complete with the full set of performance enhancements, or as a field upgrade kit to an existing AHV-IV 362 vibrator. This concludes our presentation for today, and I thank you for joining us. If you would like to learn more, please visit our website at iongeo.com.